So jumping into lesson 10.9, we've been looking at systems of equations, and now we're going to look at systems of inequalities. So we're going to look at our less thans and our greater thans. And so your big idea, the graph of the solutions to a system of linear inequalities, is a region bounded by the lines. And so we've already put inequalities like greater than or less than on a graph, and we had to shade part of the graph to represent the solution set. And we said that any single point in that region was a solution to that linear inequality. Now, we're going to have a system of inequalities, so there's going to be more than one inequality. And so basically they're both going to get put on the graph. They each have their own shaded region, but the actual solution to the system, not each individual inequality, but the system, is going to be where those shaded regions overlap. Okay, so let's take a look at how this is going to go. So if we look at example number 1, we're going to graph all the solutions to this system. Okay, so we want to find out where do these solutions overlap. So let's start with x is greater than or equal to 0. Think about it for a second as x equals 0. We'll worry about the shaded in a second. But if x equals 0, anytime we have x equals, we come to our x-axis, and we know it's going to be a line that is vertical. And it's going to hit the x-axis at whatever this number is. So if it said x equals -5, it would be the line vertical up and down that hits -5. But in this case, since it's x equals 0, this is going to be straight up and down. It's going to cross the x-axis at 0. And be perfectly horizontal. Now, remember when we draw these, sometimes they're dotted. This one specifically, though, has that equals to line, and so it's going to be solid. And so what this line actually is the y-axis. So the equation of the line that sits on the y-axis is x equals 0. And let's come back to the shading after we have the other one up there. So y is greater than or equal to 0. Think about it like the line y equals 0. Well, any line that has y equals something, come to our y-axis. It's the line that hits the y-axis. It's a horizontal line. And it's going to hit the y-axis at whatever the number is or the value is here. So if it was y equals 5, it would look like this, go straight across. But it's y equals 0, so it's going to hit at 0. So again, let's do this in a different color. We're going to have this line horizontal, and it hits the y-axis at 0, and it's solid because it's got that equals to. Now, coming back to our first line, it says x is greater than or equal to 0. So we need to shade the region that's greater than, and when we looked at these ones that were straight up and down and vertical, less than is to the left as the numbers get smaller on your number line, and then greater than is to the right. So this orange line, the shaded region for it specifically, is all of this. But this isn't the answer to the question. That's just that single inequality solution set. So any point in there satisfies x is greater than or equal to 0. But it doesn't necessarily satisfy y is greater than or equal to 0. So if we look at that one, we got this line, greater than, when you have a horizontal line or any diagonal line, is above it, and less than is under. And so the shaded region just of y is greater than or equal to 0 is going to be everything above this line. Okay, and you could shade it in as much or as little as you like. Now, the actual solution here to the system, meaning of both of them, is where they overlap. So this yellow part out here, that's part of the solution for y is greater than or equal to 0, but it's not part of the solution to our system. And this orange shaded region down here, that's part of the solution set for x is greater than or equal to 0, but it's not part of our system. So our system is going to be all out here, where these two regions overlap. And so any point that we pick out here, and obviously further than this graph shows, Any point in this region, basically quadrant 1, is going to satisfy the system, meaning it's true for both, meaning any point that I choose in here is going to be greater than 0 when it comes to its x value and greater than 0 when it comes to the y value. And think about why that makes sense. Any number greater than 0 for either one of these, any number greater than 0 is a positive. So this is the region where all numbers are positive, the x's and the y's, and we're looking at this. And now since these lines here too are included, okay, they are also part of our solution set. Now, we're going to go to example number 2. For this one, I'm not going to use all the colors. We're just going to work on shading the actual region that is the solution. So now we've got 3 of them. So we're going to start with y is less than or equal to 3. That's like the line y equals 3. So again, anytime we have a y equals a number, x equals a number, this is either horizontal or vertical. Look at the letter, find that axis, that's where it hits. So it's going to hit at y equals 3. It's going to be a horizontal line. And it's going to be solid. Now, as you look down, not all of these are going to be solid, but this one's going to be solid. And we're going to save the shading until we've got all of these on the graph. Okay, next. X is greater than -2. That's like x is equal to -2. So I'm going to come to my x-axis and find -2. That's the point that it's going to hit. This is a vertical line. And this one's going to be dotted. Okay, because it doesn't have the equals underneath. So it's going to go straight up and down and be dotted. Okay, and our last line, y is greater than x minus 1. That's just like y equals x minus 1. We can draw this. We have a slope and an intercept, so our intercept is -1. That's where it hits the y-axis. And then our slope here is 1. So slope equals 1 over 1. Y-intercept is -1. So we're going to go up 1 over 1. And down 1, left 1 when we're going to go the opposite way. So here is this line. Now for this one, I want to only shade in the solution to the system. So we kind of have to think about all of them at once, even though we're not going to shade it. So y is less than or equal to 3. Here's the line. So less than would be everything under. So if I shaded everything under this line, that would be the solution to that one. X is greater than -2 is this line. Greater than is to the right. So far we have anything that's under the orange line, but it also needs to be to the right of the black line. And then if we go to our very last line, it's either going to be shaded under it or over it. Oh, and I just realized that should be dotted. Some of you probably realized that as I was doing it. This should be a dotted line, not solid. It does not have that equal sign. Okay, so it's just greater than, not greater than or equal to. So just greater than. So greater than would be anything above it. Okay, so we need the region that is under the orange, to the right of the black, and above the blue. And so that region is going to fall in here. Now, if at first it helps to kind of shade all of them and see where it overlaps, that's fine. If you would have done that, the orange region would have been everything under here. The black region would have been everything to the right over here, including up here. And then the blue region would have been everything above that line. And then you can see the spot where all of those are going to overlap is that bound region here by those lines. But as we get better at these, we don't want to have to color our whole graph. We're just going to shade the solution set. And so you would only be shading that triangle that you find right there in between all of it. All right, let's flip it over and look at the ones on the back. So let's graph all the solutions to this system. So starting with y is less than 2x plus 3. Okay, so our y-intercept is 3. Slope is 2 over 1. And looking at the inequality, this is a dotted line. So let's make sure we get all that. I'm going to do this one in pink. So we're going to start at y-intercept of positive 3. And then we're going to use our slope of 2 over 1, up 2 over 1, up 2 over 1, going backwards down to left 1, down to left 1. Okay, and this is going to be a dotted line. So it's not included in the solution set. Then our next line, y is greater than 2x minus 2. Y-intercept is negative 2. Slope is 2 over 1. So notice they have the same slope. They're going to go up at the same rate. Think about what that means. This one goes up like this. The other one's going to be somewhere else in the graph, but also go up like that. These are going to be parallel lines. This one also needs to be dotted. Okay, so this one was my pink. And we're going to do this one in blue. So starting at y-intercept negative 2, it's right here. And we're going to use our slope of up 2 over 1. Down to left 1. These will run parallel, and they will never touch. This is also a dotted line, so it is not included in the solution set. And it's okay if you don't have colors. I think it's just easier to see right now with the colors. And so now let's go back. The pink one says less than, so that would be everything under it. And the blue one says greater than, which would be everything above it. And so the solution to this system is the part where those overlap. So everything under the pink, but also over the blue. And so that's going to be the region right in between it. And so the answer is the shaded region. Okay, so let's make sure that you know that you don't have to write an ordered pair here. The answer is the shaded region. And it's where those two overlap. So if we would have colored both of it, the whole bottom would be pink, the whole top would be blue, and the overlap section is our solution set. That's the answer. Okay, so one more. Let's see what happens down here. So starting with y is greater than or equal to 4x plus 2. It's got a y-intercept of 2. It's got a slope of 4 over 1, and it is a solid line. Let's do this one in yellow. So we're going to start at our y-intercept of 2, and we're going to use our slope of up 4 over 1. So go in the other direction, down 4, 1, 2, 3, 4, left 1, down 4, left 1. This one's going to be a solid line. Okay, and our second line, y is less than or equal to 4x minus 3. Y-intercept is negative 3. Slope is 4 over 1 again. So since their slopes are the same, they're going to be parallel once again. Now let's take a look. This also needs to be solid because we have that equal sign. And so we're starting at our intercept, I'm going to make this one blue. We're going to start our intercept of -3. 1, 2, 3. And then I'm going to use my slope of up 4 over 1. 1, 2, 3, 4, 1. 1, 2, 3, 4, 1. Down 4. 1, 2, 3, 4, 1. This is also solid. And while my lines are not perfect, we can see those are parallel, and the lines themselves are never going to cross. Now let's look at the solution sets here. The yellow line says greater than or equal to, so that's the area above it. So that would be the above the yellow. And the blue says less than or equal to, and so that's the part that's below. So just visually, I want you to see this. The blue one is less than, so everything under it. So the blue region's right here. The yellow region says greater than, so it's everything up here. But on your paper, you don't need to shade those. So if this was an either or, then those are all the solutions. But when we're solving these systems, we're looking for where do these overlap? Where are the points that will solve both of these? So anything shaded in yellow will solve the first one. Anything shaded in blue will solve the second one. Where do they overlap? Where is there a point that solves both of these? And the answer is there is none. This is a case of no solution. So it is possible to have two shaded regions that don't overlap. And in that case, you're going to have no solution.